Hello everyone, welcome to Kasiano Easy Math. In this video, we have here exponential equation 5 to the power of x equals 3x plus 3. And in here, we'll be solving for the real values of x. And before we go ahead on our solution, I would like to say for those new to my channel, I would appreciate it if you can hit the like button and subscribe for more videos. Thank you. And now we go ahead and any one of you guys who would like to try and attempt solving the equation, just feel free to pause the video. And so how do we solve this kind of exponential equation? Can we apply the logarithm on both sides right away at this stage? Probably not, right? And so here in this video, we'll be using Lambert W function to solve this equation. And in order for us to solve this kind of equation is we have to have the format of an equation in the form of x times e to the power of x equal to some constant. So this means that we have to convert the equation into this kind of format. We're going to have all the variables on one side and the other side will be just constant, like here is 3. So how do we convert this equation into that form? X times e to the power of x. And so we go ahead with our first step. So right hand side, we can factor out 3, right? So we factor out 3. So now we have 5 to the power of x equals 3 times the quantity x plus 1. And the next step would be combine all the variables on one side of the equation, right? Can we move this to the other side, or we're going to move this to the right hand side? If we move this 5 to the power of x to the right hand side, then we'll be dividing the whole equation with 5 to the power of x, right? And taking the constant to the right, that means we're dividing it also with 3, right? The whole equation will be divided by 5 to the power of x times 3. So from here, so 5 power of x divided by 5 to the power of x times 3 equals 3 times x plus 1 divided by 5 to the power of x times 3. 5 to the power of x cancelled. And the right hand side cancel 3. So we have left hand side is 1/3 equals x plus 1 divided by 5 to the power of x. So from here, we're putting the 5 to the power of x to the numerator. So we have 1/3 equals x plus 1 times 5 to the power of negative x. And so from here, if you notice, the factor over here, x plus 1, and the exponent is negative x. Our target then is to make the exponent look exactly like this factor right here, x plus 1. And yet we have negative x as an exponent. So how could we manipulate this exponent, make it appear the same way as x plus 1? And so in this case, we're going to multiply the whole equation by 5 to the power of negative 1 then, right? And since the exponent is negative x, so we'll be multiplying the whole equation by negative 5 to the power of negative 1. Okay? So multiply the whole equation by negative 5 to the power of negative 1. So now, the left-hand side is negative 5 to the power of negative 1 divided by 3 is equal to x plus 1 times 5 to the power of negative x times 5 to the negative 1. This is negative. So now, let's simplify the equation. So this is negative 1 over, putting down 5, exponent negative 1 will be in the denominator. So that will be 3 times 5 to the power of positive 1, right? And the right hand side we have negative of x plus 1 times, here we can combine this, right? So based on exponent formula, that is, we have a to the power of m times a to the power of n. We ended up adding the exponents, right? We have the same base, so we have a to the power of m plus n. So we have here 5 to the power of minus x plus minus 1. So that is negative x, negative 1. And so simplifying this further, we have negative 1 over 15 denominator equals distributing the negative sign. So we have negative x, negative 1 times 5 to the power of negative x minus 1. And here the expression 5 to the power of negative x negative 1 can be written as, here it's 5 power of negative x negative 1 is same way as e to the power of ln of 5 to the power of negative x negative 1. Since e to the power of ln cancel each other, this becomes 1, right? So we ended up with just 5 to the power of negative x negative 1. So that's the value of that. So now we're plugging in this value of 5 to the power of negative x negative 1 into our equation right here. The value is, the new value is here. So we have negative 1 over 15 equals negative x negative 1 times e to the power of ln of 5 to the power of negative x negative 1. And so now we're getting closer to our target format, right? But then take a look, something is missing, right? We have this negative x negative 1, that's the exponent. We still lack this part of the value ln of 5. So what should we do now from here? So we multiply the whole equation by ln of 5, right? So we have to do that, multiply it by ln of 5. Since the exponent rule of logarithm, we can put this exponent on here as on the front as coefficient. So we ended up with ln of 5 times quantity negative x negative 1, right? So let's do that. And so we're writing the equation, moving the exponent to the front. So we have now negative 115 equals negative x negative 1 times e to the power of negative x negative 1 times ln of 5. So now take a look. If you notice, the exponent is in this format now. The difference is we don't have ln of 5 in the base. So what we have to do is multiply the whole equation by ln of 5, right? So we have here now, multiply the whole equation by ln of 5. So we have here on the left hand side is negative ln of 5 divided by 15 equals ln of 5 times negative x minus 1 times e to the power of negative x negative 1 ln of 5. So now our equation is at the desired format we were trying to target earlier from this format, right? So our value of x over here is this whole thing right here. That's the same thing on the exponent, right? So this is in the form of x times e to the power of x with some constant, right? So constant here is negative ln of 5 over 15. And here, right hand side is in the form of this format, our target format. So we can now apply Lambert W function to solve for the value of x, right? So by applying the Lambert W function into this equation, we're going to have w sub x times e to the power of x. We'll be having the value of x. We extract the value of x over here. So let's equate the equation now and apply Lambert W function, right? And we can switch the left hand side with the right hand side. So we can rewrite that as ln of 5 here times the quantity negative x negative 1 times e to the power of negative x negative 1 ln of 5 equals negative ln of 5 over 15. So we have the desired format that we want right here now. So now we can apply the Lambert W function to the equation. So we have w sub ln of 5 times minus x minus 1 times e to the power of negative x negative 1 times ln of 5 equals w's of the right hand side is negative ln of 5 divided by 15. So we have here the value of x on the base as well as on the exponent. And so we have ln of 5 times quantity negative x negative 1 equals w sub negative ln of 5 divided by 15. So from here, solving for the value of x, we have negative x negative 1 equals w sub negative ln of 5 divided by 15 divided by ln of 5. And so we have x is equal to negative w sub negative ln of 5 divided by 15 divided by ln of 5 minus 1. So this is our final answer. And so based on our solution value of x, how do we know if we have just one solution to the equation? If we take a look, the quantity inside the parentheses right here, negative ln of 5 over 15, if this value is in between 0 and negative 1 over e, then we would have two solutions or two values of x. That is, when x is less than 0 and x is greater than or equal to negative 1 over e. So in here, in this case, we would have two solutions. There would be two values of x. And in our case, x, we're referring to this value right here in the parentheses, negative ln of 5 divided by 15. And so our value over here, negative ln of 5 divided by 15, that is, if we do it over here, that's negative 0.107. And this is less than 0. And here the value of negative 1 over e is equal to negative 0.368. So this is less than the value of x over here. We're referring to this value in the parentheses. Okay, so this means that we have two solutions. We have two values of x. And on the other way around, if our value of x over here, we're referring again to this value in the parentheses, negative ln of 5 over 15. If that value were greater than 0, then we will have just one solution or one value of x. So this is without the knowledge of what our equation looks like. So if we're going to graph our equation, it should show right there exactly what we're talking about. So let's see the graph of our equation. So we have here the graph of the function 3x plus 3. So this is the right hand side of our equation. 3x plus 3 is a linear function. So this is 3x plus 3. So that's the graph of it. At y is 0, we have x is negative 1. And at x is 0, so we have y here is at 3 points on the scale on the y-axis. And the function 5 to the power of x, exponential function, its graph is like this. If you notice, we have two intersections over here crossing the line twice. Right here somewhere almost like negative 1, somewhere like 0.9. So, and the other side, we have somewhere positive x 1 point something, probably like about 1.10, 1.15, somewhere there. So we have that two intersections. So here on the x-axis, that is like positive 1.15 somewhere. Here, the other intersection is somewhere almost negative 1. That's negative 0.9 somewhere there. Okay. So this is the graph of 5 to the power of x. So back to our solution value of x, we have two branches. That means we have two answers or two solutions to our equation. So here on the w, we have two branches, w sub 0 and w sub negative 1. So this is considered w sub 0. And the other value is x is equal to, here is w sub negative 1, so negative w sub negative 1 times the quantity negative ln of 5 over 15 divided by ln of 5 minus 1. So this is another value of x. So these are our values of x, which correspond to the 2 points of intersections. And so that's all for now. And for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. Hit that notification bell so you get updated when I upload new videos. Thank you for watching. Have a great day, everyone. I will see you in the next video. Bye.